The object shown is in equilibrium. We want to find the magnitude and direction of the frictional force. If we look at the forces acting on this object, we have its weight, 10g. There will be a normal reaction force perpendicular to the surface. We can resolve the weight into components perpendicular to and parallel to the surface. This is 30 degrees, 60 degrees, 30 degrees, so the perpendicular one must be 10g cos 30, and you should remember this so you don't have to work through that every time. Parallel to the surface is 10g sin 30. The friction is going to act in this direction, although it doesn't matter which direction you put the friction onto the diagram. If you draw the friction in the wrong direction here, the answer will simply come out as negative. We can now ignore the weight since its components do the same thing as the original weight. It's just that the components are in the directions we want them to be. If we look perpendicular to the plane, although this isn't directly of interest to us in this question, we can see that we have r in the opposite direction to 10g cos 30, and since the object is in equilibrium, these must be equal. Now considering parallel to the plane, we have 40 and friction acting up the plane, and 10g sin 30 acting down the plane. Once again, for the object in equilibrium, these must balance out. We want to find the frictional force, so we can rearrange to give us friction is 10g sin 30, take away 40, so this is 10 times 9.8 times the sine of 30, which is a half, take away 40, and this calculates to 49 take away 40, or 9 newtons. Since the answer came out as positive, it must be in the direction drawn in the diagram, which is up the slope.